Ever pondered over the inner workings of a three-phase induction motor? Well, today's the day we delve into the intricate details of this fascinating piece of machinery. To kick things off, imagine the heart of this motor, the stator. It's a stationary part that houses a three-phase winding. Picture three sets of coils, each representing a phase, wound in a specific arrangement to produce a rotating magnetic field. The power supply to these coils is three-phase AC power. Now, shift your focus to the rotor. It's the rotating part of the motor, sitting comfortably within the stator. Cast from aluminum or copper, the rotor is designed to create its magnetic field when the stator's magnetic field cuts across it. So, how does this motor start spinning? The secret lies in the interaction between two magnetic fields. When the stator's three-phase winding is energized from a three-phase supply, it produces a rotating magnetic field. This rotating field cuts across the rotor conductors. When it does, it induces a current in the rotor due to Faraday's law of electromagnetic induction. This current, in turn, produces its own magnetic field around the rotor. As a result, the rotor's magnetic field tries to catch up with the stator's rotating field, causing the rotor to spin. And voila, that's the motor in action. But what if the rotor catches up with the stator's magnetic field? Well, it never does. If it did, the relative speed would be zero and no current would be induced in the rotor, bringing the motor to a standstill. So, the rotor always spins at a speed slightly less than the stator's magnetic field. This difference in speed is known as slip, a crucial concept in the functioning of three-phase induction motors. To recap, the three-phase induction motor operates based on the principle of electromagnetic induction. The stator houses a three-phase winding that, when energized, creates a rotating magnetic field. This field cuts across the rotor, inducing a current that generates its own magnetic field. The interaction of these two fields sets the rotor in motion. Remember, the rotor never fully catches up with the stator's field, maintaining a slight slip to ensure continuous operation. So, the next time you see a motor whirring away, take a moment to appreciate the elegant dance of magnetic fields that keeps our world in motion.